Yes. Oh, don't. Echo.
All right.
Hey, is the sound better now?
Yes.
Yes, sir.
Excellent. All right, welcome to our July virtual chat. We are mostly archaeology themed today. We did have some miscellaneous business, I guess, to go over. First, just a few things. One of those is I would like to point out that on the CRO webpage, which let me share my screen with you. So as it comes to tribal consultation, we've been seeing some submissions that have tribes listed that are not signatories to our consultation MOU and that we don't typically consult with. Of course, we are interested in consulting with more tribes, but we're not quite sure how these other tribes are coming into the mix or where you're finding them. So somewhere on this page, we have, here we go, under documents, we need to reorganize this. We do have a list of tribal contacts by county. Some of the tribes are for the entire state. Just in case you're not aware with this, this is kind of the master list of the tribes that we traditionally invite for all of our projects. So this would be your go-to place for identifying those tribes that need to be included as potential consulting parties. If you are aware of a tribe that has an interest in the county that's not on this list, I'd say please run that past our tribal liaison, Taylor Payne, and we can reach out to that tribe and see if they do in fact want to initiate consultation with us. But please do go ahead and make use of this list when you're trying to identify which tribes would be the proper tribes for consultation. More specific, well, less specific, I guess. Section 106 documents. We've had a number of cases where, say there's a historic properties report and an archaeology report that are both in review around similar times. we've had people respond to us that they believe it's CRO policy that those documents must be distributed to consulting parties together. I'm not aware that that's ever been CRO policy. If it makes sense to distribute them together, like they are likely to be ready at the same time or within a short amount of time of each other, that's fine. But I don't think there's a situation in which, say, we would want one of those reports just held for 3 months or, an extended period of time just to wait for the other report to be ready. Because, during that time, if it's possible to distribute that and get it to SHPO for review and receive their response and any consulting parties' responses before the other document is ready, that would really be preferable. So, use your judgment, but don't go into it under the assumption that we, for some reason, require those documents to be submitted simultaneously, because that is not the case. I'll also point out, let me share my screen one more time. Back to the CRO web page. Blanked on one. Yes, so in one of the pieces of guidance that we have from 2021, I'll need to update this, but I've become aware of, or I am aware that there's an error in it, and I just wonder if it's causing any confusion. So the area of potential effects for archaeology is defined as basically all of the existing and proposed right-of-way. And that has always been the case because things happen in the right-of-way, things that we don't necessarily know will happen. There are INDOT standards that prohibit certain activities during construction to take place within the construction limits, which limits them to the rest of the right-of-way. If their utility relocates, that could happen. So anyway, basically for our undertaking, we want to cover all of that right-of-way. And so the error here is that it says it's largely synonymous with survey area. That is not correct. The area that is surveyed does not determine the area of potential effects for archaeology. That's always going to be essentially all of the project right-of-way, existing and proposed. This probably should say it's more or less synonymous with project area, which is sort of accurate. So if I will get that updated, but I just wanted to put that out if that's causing any confusion. The survey area does not affect the APE. And if you're surveying a larger area because the project limits aren't defined, that does not increase the archaeological APE. Generally, though, it is the case that we don't really need to talk about the archaeological APE in most documents. Probably reserve that for the 811 documentation. For archaeological reports and things discussing archaeological reports, it's generally good enough to talk about the survey area because that's the area that's been investigated and cleared. And as long as it encompasses the archaeological APE, everything should be fine. Let me find the question.
Oh, you just raised his hand.
Oh, yeah, Sam.
Yeah, so just for clarification, if we have like a 9-mile HMA overlay with, say, 4 culverts in there, do we have to look at the existing right-of-way for all 9 miles or just where they have the culvert work maybe being done?
No, that's a great question, Sam. Thanks. So yeah, this is the document. Actually, I had and again, sort of discusses a lot of that. And so essentially an activity like HMA overlay, if nothing else were happening, that would be category A of the MPPA. So if the only work that's happening in a large stretch of the project area is category A type work, we wouldn't look at that normally. And so you don't need to investigate all of that. It would only be areas where there is new ground disturbance. I know it's in this document. Areas of new ground disturbance. So if it's 9 miles of HMA overlay and you've got 3 culvert replacements that are going to have ground disturbance in undisturbed soils, you would just look at the work areas for that new ground disturbance. The portion of it that's category A work within the existing right-of-way doesn't need to be reinvestigated. We do ask that it's included in the records check for the project, though. So your records check would cover that entire 9-mile length of the project. And one of the reasons for that is just in the off chance that, say, there is a previously recorded site that's either been previously determined to be eligible, or, looking at it, say it was recorded a long time ago, but looking at it now, you would reasonably think, well, yeah, I would recommend that site potentially eligible. If we find that those sites go up against the right-of-way, or particularly if they're recorded as being within the right-of-way, we don't necessarily need to reinvestigate them, but we want to know that so that we can have a commitment in place just to avoid those site areas, to ensure that some unforeseen, activities during construction don't inadvertently impact that site. So we wouldn't need to reinvestigate it, but we want to know if there are any eligible or potentially eligible sites recorded within the right-of-way so that we can have an avoidance commitment. Did anyone else have stuff? All right, I guess that's the majority of it. I guess I'll say one thing about also archaeological reports. Interpretations of sites that are identified in the field, we'd really like to keep those as grounded in the results of the survey and the records check as possible. So a lot of times you can make a reasonable inference that if you find a historical scatter that's on the property or next to a parcel where, say, there was a house site recorded on an 1871 plat map or whatever, and the artifacts date from around that time, yeah, you can make a reasonable inference that those are likely associated. But we don't need to explain every artifact that we encounter in the field. So if you find that historical scatter out in the middle of the field, there are no known roads near there, no structures mapped near there, you can really just say that, just document it, make an eligibility recommendation for it. We don't need to find a storyline that might explain why that site is there. So, avoid, I guess, spinning sort of fictional scenarios about what somebody might have been doing out in the middle of that field when they dropped some artifacts. Or, I guess, particularly avoid speculation in the absence of some kind of documentary evidence that, maybe there was a very short-term historical habitation there and somebody had a house for a period of time, but it wasn't there long enough to be captured on any plat map. That's going beyond what we can reasonably infer from the artifacts and from the background research. And that's a little bit concerning because that might point toward that site being potentially eligible. If we did have reason to think that there was single occupant short-term occupation historically someplace, if there were any potential for intact deposits, that would be a historical site that's really pretty interesting and might be potentially eligible and recommended for more work. And we don't want to get ourselves into that kind of recommendation, I guess, based on like, well, that might be the reason it's there. If there's reason to believe that, we definitely want to know it. But if you cannot determine why some artifacts are where they are, that's fine. And this is mostly for historical sites. I don't think most of us really, if we find a few isolated flakes, try to go into great detail about the origin of that site, but people are more tempted to do that with historical sites. So for sites in general, just to sum that back up, please try to stick to what we can support with some sort of evidence. if you have a strong hunch, you can say, well, there's some possibility that this might be related to something, and that's probably fine, but don't oversell it, I guess, with strong language that would say, this is very, very likely associated with, X, introduce the possibility if you think that it's important and it's part of your due diligence for updating the archaeological record. But again, just don't go beyond what you can actually support with some sort of evidence from field work and research. And with that, does anyone have any questions about that before I move along? Nothing's in the chat. All right, let me try to get my PowerPoint to cooperate. So if you're online, are you seeing the actual presentation or the notes page? The regular presentation? Okay.
No presentation.
Oh, well then let me try this again.
Are you sharing a window or are you sharing your screen? Oh, there you go.
Okay. I think we're good now. All right, so now that I've spent some time going over the things, I would like to get into the meat of what I'd like to talk with you about today, which is essentially soils and deep testing. Part of the motivation for this is that the Society for American Archaeology Geoarchaeology Task Force recently released a statement about deep testing. This is largely kind of a survey of the state of practice across the country and includes some qualification recommendations, but it also includes this sort of handy flow chart, which is great. I think it's very useful, but it takes a lot of things into account that you would not be thinking about at a phase 1A level, which is where most of our decisions about whether or not deep testing might be necessary are made. And I think it's a little bit oriented toward people with maybe more geoarchaeological credentials than the majority of us doing phase 1A surveys probably have. So this led me to think that it was time for an update. About 4 years ago almost, we had a webinar about deep testing in archaeology, deep thoughts, and we had some of our friends from cultural resource analysts and Gray and Pape assist us with that. And I think it really made a big difference in terms of the quality of submissions that we were seeing after that. I know a lot of you really picked up on soil order as a piece of evidence that you could look at for making these decisions, which is great, but there are also other things that we need to take into consideration. So both to cover that, and this also I've been noticing, I think, just some uncertainties about soil classifications, what they mean, how to record them. So I wanted to follow up on our deep thoughts with an additional chat where we will discuss some background, very basic soils information, largely oriented toward the decision-making process for deep testing recommendations. And so the very beginning of that, we'll just start with what are soils? And how do they form? So pedogenesis is soil formation from some sort of parent material. You see these parent materials listed a lot of times when you look at the description of the soil series. So it could be alluvium, it could be glacial till, it could be residuum. They can form from pre-existing soils. But soil formation requires a few things. It requires that you have a relatively stable landform so that the soil can form, and time so that the soil can form on that stable landform. Soil formation is the result of weathering of the upper layers of the soil, transformation of the minerals that are in the upper level of the soil, transportation processes like eluviation, which is the removal of materials, illuviation, which is the accumulation of materials that are eluviated from upper levels into lower levels. Processes like that. And soil formation, it can promote soil horizonation, it can preserve it, or it can destroy it, just depending on which factors are at work. Because soil is a dynamic system. Soil formation is influenced by a number of factors. Parent material, like I mentioned, can be a combination of parent materials, which you often see, loess over residuum or loess over glacial till or alluvium over glacial outwash. Climate plays a big role in especially the pace of soil formation. So that's weathering, the temperature, moisture. Organisms, both macroscopic and microscopic. Vegetation, vertebrates and invertebrates, even bacteria play a role in soil formation. The setting of the landform is important, the amount of relief or topography. So you'll see these things listed a lot in the soil descriptions, whether they form in uplands or side slopes, on floodplains, depressions on till plains, things like that. And time, the amount of time. Soil formation is a slow process. You can look online and see estimates for how fast it happens, and you need to take those with a grain of salt because, like I just said, it depends on a lot of different factors, but it's pretty slow. I guess that's the takeaway from that. And it does depend upon, the climate and weather. Soil petogenesis happens much faster in warm, moist, humid climates than it does in cold, dry, arid climates. Important for considerations about deep testing. If the soil becomes buried, petogenesis largely stops or at least slows down greatly. So the process of burial can preserve or destroy deposits depending upon how that material is deposited. But if it's preserved, those buried soils more or less become frozen. They stop changing at a rapid pace, especially if they're buried very deeply. We'll come back, I'll touch on these things again as we move through our talk today. So here's another situation where you need to take the limits, the time periods here with a grain of salt, but just to give you an idea of soil formation processes, on the order of decades, you get plant material that establishes on the surface of the parent material. Roots move through, organic materials start to accumulate, they get broken down, organisms mix them into that upper portion. So basically on this level of decades, if you have, say, fresh alluvium or some newly deposited parent material, you start to see the formation of an A horizon. So you might see soils that have an A-C profile. The A horizon might be weak, might be stronger, depending on how longer it's there. But this is a relatively short term. On the order of centuries, those processes continue and the A horizon becomes thickened as more organic materials come into it. And silty sediments accumulate from, windborne deposits that get washed in, deposited by rain, whatever. Iron oxides form, which creates more of those rich yellow-brown colors that you see. You start to get some eluviation. You start to see some of the minerals in the clay in that A horizon move downward. They get washed downward through weathering. And that starts to create a B horizon. So over the period of centuries, you'll see a weak cambic B horizon or BW horizon. And that might show up as an ABWC profile. Over the order of thousands of years, a few thousand years, you'll see a pretty well-established stable A horizon over a B horizon that's becoming better defined. You'll see, more organic materials and humus accumulating in the A, more breakdown of minerals and transport of them from the upper horizons downward to where you start to see an argillic B horizon, a clay-enriched BT horizon develop over time. And as this happens, those upper horizons are thickening. And so, assuming there's no erosion, the depth to your sea horizon will likely be increasing as those upper horizons are forming. So that will show up as an ABTC profile. And then over a much longer period of many thousands of years, you'll have very well-developed soils. You'll still have accumulations of clay thickening your B horizon, your BT horizon. An eluviated E horizon may form. Those often don't get preserved if they're in an agricultural setting. Those often get sucked up into the plow zone. But that's a horizon where the iron and many of the other minerals and organic matter that might have been in that area get completely washed out, and you have this eluviated horizon that's left. So in these old, well-developed soils, you're very likely to see something like an ABTC or AEBTC profile. So again, just think about this, decades, centuries, many thousand years. This is basically how your horizonation works, in a very simplified nutshell. I don't pretend to be going into this from a soil science perspective or accounting for everything that could happen. But this is one way that the soil profiles that you're seeing can give you some sense into the age of that soil. And when you put that together with the parent material, it'll give you a better understanding. And this information, I have a link to it here, and I will share these slides later along with the link to the recording of this. But it's from University of Nebraska. Lincoln might be more appropriate for a Western state. So again, don't worry about what, it's already on a very general scale, but that should just give you kind of a sense of the time frame that we're looking at for this to take place. Any questions so far? Or move along. All right. So with a kind of sense about exactly what a soil is and more or less how it forms, I'd like to talk about how soils are classified. And the USDA has their soil taxonomy that you've hopefully seen or probably seen referenced. It's dry reading. I wouldn't recommend going through it, but I would recommend looking at it. It does have a lot of interesting information in it. This taxonomy is more or less a hierarchical classification. It's not completely consistent with each level of the taxonomy. And they're not all, in my opinion, equally useful for archaeology. One of them that I think everybody has become familiar with after our last virtual chat about soils 4 years ago is the soil order. Those are the 12 sols, your alpha sols, entasols, inceptisols, mollisols, altisols, etc. Those are defined based on the presence or absence of diagnostic horizons that give insight into the soil formation processes that form those soils. They can provide some information about the likely age of the soil, but I'll be giving you some big caveats on that as we move along. That is a useful thing to look at, especially before you go out into the field to help yourself decide, do I need to take an auger along with me? The suborder is based on specific sets of conditions that affected the soil formation, like the moisture and the climate. I don't see a lot of utility in this. And, if you do, please share that with me because you may know something that I don't. They can sometimes give you some insight into site potential, like aquic soils. So your aquals, aquins, aqueps, aquals, aquils, and so forth. And you'll notice that the ends of those match the soil order, and that goes down to the grade groups too, if you're ever looking at the taxonomy. So the aqualfs, alphasols, aquints, entosols, aqueps, and septosols, aquals, mollisols, and so forth, aqualts or ultisols. Anyway, if they're aquic soils, that tells you that they formed in wet conditions. So that could give you a sense that there is a fairly low potential for pre-contact sites, or for sites that might have been, sites prior to some sort of artificial drainage of those soils. But, a lot of them, I don't find a lot of utility in the suborder. I don't find any utility in the grade groups or the subgroups, so I'm not even really going to discuss those. Again, if you have a different idea and you're like, my gosh, I could not go out into the field without knowing what subgroup my soil classification is, let me know about it. But I'm going to assume for now that we're good to move on. Family is also not very important. Those are very functional. This is different, very different than the other levels of the taxonomy. They have a lot to do with what the characteristics of the soil make it useful for to people a lot of times. That can tell you a little bit about your soil potential for archaeological sites, but I don't think it's nearly as useful as the next level, the bottom level of the taxonomy, which is the soil series. And so this is what you all see when you're doing your records check and you're looking in the soil books or at the web map survey, if you're in the 21st century. Those will tell you the soils that are, what family of the soils that are classified in your survey area belong to, I guess. Not family, I shouldn't say that. What series? I can't find a better word than series. And they have some very specific information about that soils that is really useful for guiding your survey and letting you interpret the results. Soil maps and the soil map units are kind of like, they're almost another level in the soil taxonomy. I kind of think of them as an unofficial level under the series. And that's what you're really seeing when you're looking at the web soil map or a soil book. And you're seeing what soils are classified in your survey area. You're seeing these soil map units. So here's just the visual representation of that taxonomy, showing you what sorts of names you see associated with that, the family. And then those things are used to define the soil series. The soil series are specific combinations of those upper level taxa. So you'll see the series that they come up with here, Creek, Clark, Murrill, Chase. I don't think these are Indiana soils, but it was a handy graphic. And, you could just imagine some more familiar soil series there. And so when you see those soil map units, those identify the dominant series, but also localized variations within that dominant series. So if the dominant series in the area you're looking at is the Clark series, one of the soil map units that you might see could be a specific variation of that, like Clark clay loam. So the map units are more specific than the series, and they're geographically specific to a certain extent. So it's useful to understand, at least have a concept of how these soil map units are defined or how soil maps are made. And the thing I want to drive home to you throughout today is that these are classifications. They're done at a high level. They're done at a scale that is not specific to putting a shovel probe into the ground. And you'll see disclaimers on the soil maps. And I think if you go to the web soil survey and you zoom in too much, you'll see a disclaimer that, this map is not accurate at the scale at which you're viewing it. So just because you have a soil map unit mapped there, that doesn't necessarily mean that that's exactly what you'll find all through there. So the classification is not the soil, and that's true when you're looking at these map units. It's true if you're making decisions about deep testing. But the way the soil maps are made is they start by defining what they call soil landscape units. Those are specific combinations of soil formation factors and parent materials with specific landforms. Once they define those soil landscape units, Then they sample them with some limited field work and apply the soil taxonomy to them. And then they're generalized or subdivided when they find the soil series that are there to create the soil map units. So they do reflect specific localized variations in the soil, but they do it at a broad scale. It's really broader than the scale that you're working at, again, if you're out there touching metal to dirt. So here are a couple of examples. One on the left is from St. Joseph County in northern Indiana, which is in a glacial setting. I think the other one might be from Harrison County. It's definitely from southern Indiana. So you'll see that when they've done this, the one in northern Indiana in the glacial setting is a good deal simpler because the topography is less complex, for one thing. The parent material is probably relatively uniform. It's probably largely glacial outwash or till. Whereas the one in southern Indiana is a good deal more complex because there's more complex topography and maybe more variation in the parent materials as well. And so, you know, that's this process of creating these soil landscape units and classifying them into soil map units. You know, the outcome really does depend on the setting because setting is one of the things that's taken into account there. Now, when you look at the soil maps, you'll see that they all have symbols. These are soil map unit symbols, which you often see and report in your reports along with the soil map unit name. If you haven't noticed, there are conventions for what these symbols mean. So the first thing you see it on this map, and you're seeing CS or BM or CT. Those are variants of the soil series. You'll often see some suffixes attached to those. If you see one, the first one that you see is usually a letter, and that corresponds to the slope. If there's no letter, that means there's no variation in slope, and most likely it's a fairly level soil. If you see an A, it's usually fairly level, 0 to 2%. They increase in slope 2 to 6. C might be 6 to 12. You know, F might be 25 to 75% slopes. Those cutoffs, whether it's 0 to 2 or 0 to 3 or 6, 12 to 18 or 16 to 20, those might vary between different soil series or even among different variants within the soil series. But what doesn't change is that, as you go up through A, B, C, D, E, F, it's indicating steeper slopes generally. The second suffix that you may see is a number, and that corresponds to erosion. So if there's not a number at the end, the soil is not eroded. If the soil is eroded, you'll see a 2 at the end, or if it's severely eroded, you'll see a 3. I don't think it goes beyond that. Oh, it may, I don't know. It's fairly uncommon if there is a 4. I don't think I've ever seen it. So if you put those things together, your specific soil variant, say, is Hagerstown Silt Loam, that's HA. If it's 18 to 25% slopes, you add an E on it. If it's eroded, there's a 2 on the end. Same thing for Hagerstown Silty Clay Loam, different variant, different symbol, HG instead of HA. 6 to 12% slopes, you get a C. Severely eroded, there's a 3 at the end. And so those symbols are very specific to that entire soil map unit name, because you see that the symbol encodes all of that information about slope and erosion. And if it's frequently flooded or shallow to bedrock or, there can be variations on it that may show up as a different symbol. So whatever, that combination of stuff is specific to it. So please give that entire soil map unit name verbatim and put the symbol along with it. Don't stick the symbol in the end of it. Don't delete parts of the soil map unit name because, that is the soil that is classified and mapped at your location. And if you change the name of it, you're no longer reporting the soil that was classified. And so you'll see this if you look in the descriptions in the soil books too. It's the same thing. You'll see Hagerstown silt loam, 18 to 25% eroded. You know if you see this slope and that you're going to have a letter and a number at the end. So when we look and we see a soil map unit symbol that has a 2 or a 3 at the end, and we see that your soil map unit name does not say anything about the soil being eroded, we know that there's some mismatch there and there's a problem, because the name really ought to say that it's eroded. If there's a 3 at the end, it's going to say it's severely eroded. So that's why we make a lot of the comments that you see about basically not messing around with the soil map unit name, not putting the symbol somewhere in the middle of it, not deleting parts of it, making sure that the symbol actually maps the name as reported. So hopefully that kind of explains what those symbols and names mean and what we're looking for when we see them in reports, which is basically we're looking for you to copy and paste them and not make improvements. So moving from sort of the bottom or below the bottom of the taxonomy back to the top, I think many of you have become aware of the soil order is a thing to look at, and it is associated with the level of soil development. That's part of what's taken into account when it's defined. Therefore, it is somewhat correlated with the age of the soils, but that varies. For instance, alpha soils, if you look at the descriptions of them or at the taxonomy, they're often associated with Pleistocene age deposits, which would be older than most human occupation. And so you would not expect to see buried sites in them. And that's true, particularly in the uplands, but that's not necessarily true in alluvial settings, because there can be well-developed alpha soils that are of Holocene age in some settings, for instance, in southern Indiana along the Ohio River and its tributaries. And Russ Stafford actually did document buried early to middle Holocene sites in well-developed alpha soils along a tributary to the Ohio River. I have that reference at the bottom. So again, the classification is not the soil. Don't just assume that by seeing that something is classified as an alpha soil, that it's older than human occupation. You also need to look at the setting of that soil and the parent material. Because if it's an alluvial alpha soil, and particularly if it's in a setting that may have highly active soil formation, like and the potential for buried sites, I would not rule it out strictly on the classification. It would still be prudent to take your auger along when you're working there and seeing exactly what you really are seeing below there and whether it does appear to have any potential for buried sites or not. But when you're thinking about the soil orders, these are some of the most common ones that come up. Obviously, there are 12 of them. Not all 12 will pertain to the state of Indiana. You will see others than this, but these are very common ones that you run into. Entisols generally are the youngest soils. They've not had time for significant horizonation to develop. Could be a C profile or an AC profile with no B horizon. Often, and this is where setting is important, they're often associated with active landscapes. And that's probably why there's a C horizon with no horizonation above it. They often have a low potential for buried sites, but not always. Inceptisols are young soils, little or alluviation, and so the development of the B horizon is weak. You'll see cambic BW horizons typically in these soils. Mollisols, older soils, often developed in grasslands or under prairies. More extensive alluviation, and you will see that clay BT horizon. And so this is think back to the slide, we're looking at decades and centuries. Here we're up to a few thousand years. Then alpha soils are your many thousands of years old soils, very old, extensive development, alluviation associated with Wisconsin age odor, and older glacial landforms in the upland areas again. But again, they can be the result of early Holocene alluviation and just reflect more rapid soil, more well-defined soil development, even though they are of a slightly younger age. And so, again, don't discount alpha sols for cultural deposits without a good justification for it. Yeah, if it's on an upland ridge, and but in alluvial settings, give careful thought to alpha sols in case there is a potential. Some of the things that we've learned also about these soil orders is that, what's mapped can essentially be wrong. Again, when they're out doing ground truthing for soil mapping, it's pretty limited. They're doing limited amounts of investigation over a large area and doing a lot of extrapolation. So the classification is not the soil, and what's classified may not be correct. Because when you get out into the field, you may find that the soils that you're digging into are older or more developed than the mapping implies or the classification, or younger or less developed. And we saw this in some of the phase 1C investigations for I-69 when Grain Pape was doing phase 1C for work for us out there. Pat Trader talks about this in an article that he wrote, which I didn't think to link here, but I can pop that link in when I share the materials. But, there were soils that were mapped as entasols that when they were dug into, they had over thickened A horizons and soil development that was more characteristic of mollisols, and they did contain buried sites, somewhat deeply buried sites. And also the scale. Remember, the soil mapping is at a broad scale, and it's not meant to apply to the level of specificity that you would like when you're out there walking across the ground or putting in your soil probes. And it was not created for archaeologists, and it's not intended to be interpreted at such a fine level. It is a broader scale representation of the trends and the variation that's in the soils. And those map units also, they reflect the dominant series. There are almost always associated soil series or sibling soils that are present, but they're not mapped at the scale of the soil survey. So, in this case, you have a Hagerstown silty clay loam soil that's very specific. But if you look, you can see here, it's actually about 80% that soil, about 10% Apaquan, 5% Clarksburg, 3% Merle, and another 2% rock outcrops. And, the percentages and identities are going to change as you look, but this is very common. I'd say it's almost typical that when you have a soil series mapped or a soil map unit that's mapped and you're looking at it, there are likely to be associated soils that are present in that same area and just not shown on the map. And so when you're shovel probing, you should not be that surprised to see other soil profiles that don't match the dominant one that's mapped and may be quite different. But if you were to go in and look at the associated soil series, you may see that it's actually quite similar to one of those. So, again, the classification is not the soil, and there is more complexity in the ground than what you'll see on the soil map. So I guess if you've ever wondered why you see a lot of variation or a certain amount of variation within what looks to be a big uniform area of one soil type, this is one of the reasons. It's not intended to capture the more minor variations. It's meant to capture sort of the dominant soil in that area, but you will see variation. So what does all of this mean in terms of thinking about deep testing? Well, start planning at your desktop review stage by asking, what is the buried site potential? And the potential for buried sites, well, it requires a few things. Obviously, it requires a setting or landform that would have had the potential for sites to be on it and become buried, which entails a stable surface long enough for people to use it and create cultural deposits that could become buried. And it requires a mechanism for those sites to become buried. In Indiana, this is primarily alluviation. And so if you don't see alluvial soils mapped in your area, there's really no reason other than specific circumstances that are very specific, like if there's historical fill that might be covering sites and burying them, or if you're in a topographic setting where you could have colluvial deposition coming down and burying sites near areas of relief. But in general, in terms of the soil map, if you don't have alluvial soils, then you don't really have a reason to suspect that there would be a potential for deeply buried sites. The type of alluvial deposition is very important here. It must have been low energy deposition to preserve sites, because higher energy deposition will tend to destroy sites by scouring them away. So low energy deposition, think of this as relatively still water that ponds up and dissipates over time. And as that happens, the sediments that are suspended in it get deposited, and they'll tend to be finer grained sediments, silty, clayey sediments. Whereas if you are seeing alluvial deposits that are sand and coarse sand and gravel, it requires relatively high energy water flow to move those things around. And that tends to destroy whatever sites might have been present because of scouring. And it can be in the middle, you can have alluvial deposition that both destroys partially and partially preserves sites. We also saw that with some of our phase 1C work on I-69, settings where much of the site had been scoured away by alluvial action, but then was buried, and basically we were just seeing like the bottoms of features, or even feature matrix had essentially been washed away by somewhat high energy flow, but that still left, say, the concentrations of fire cracked rock that had been in the feature in place, while removing much of the, I'd say, more interesting information that might have originally been in that feature. So the energy of the alluvial deposition is very important in terms of whether sites are going to be preserved or not, and whether they'll be buried intact, buried somewhat intact, or completely destroyed. So that mapped soil order, while it is a thing to consider because it does give you some idea of the age of the soils, it's only one thing. As I alluded to earlier, it's not really meaningful to look at the soil order in isolation if you don't also consider what the parent material is. Is it alluvial, which is what you want to see almost all the time for buried sites, and also the setting or landform. Yeah, I mean, you don't really need to know if it's an alpha sol, if it's a glacial soil, for instance, because glacial soils are by definition generally going to be soils that are too old to have habitation on them that is that has not happened since the material was deposited and the soils have formed. So any archaeological deposits in glacial soils are very likely to be out or near the surface. And you don't need to know the soil order to know that glacial soils are old and would only have site potential near the surface. That's probably something that you should be thinking about, maybe even before you worry about the soil order, but certainly take it into account. And also, a glacial soil does not have the mechanism to bury sites because it's material that was deposited by the glacier. Tiny glaciers have snuck back to gently lay down some additional layers of material since that time. So if you're not in an alluvial setting, you may have alluvium over a glacial soil that you'll need to look at. My experience, those are often, around tiny drainages that are somewhat entrenched, and what you see is relatively disturbed channel deposits that have a shallow layer of alluvium over pretty much intact glacial deposits as you get away from that channel. But it behooves it's incumbent upon us to check that. If we see that we have some alluvial soils and we can't necessarily rule them out based on other information. Now, that might be a case where in a glacial setting like that, if you have some alluvial deposits and those alluvial soils are also an alpha sol in, say, the northern half of Indiana, in that case, that might be a good indication that even that alluvium itself is quite old. But, just think about it. There's a difference between alluvial deposition around a small drainage channel in northern Indiana and what you might see along the White River or the Ohio River or some other major drainage like that in the southern part of the state. So these are pieces of a puzzle that you need to consider more than one of them. There's no one thing. So that parent material is very important because you need alluvium. Alluviation is the primary mechanism that's going to bury sites. And then setting our landform. So alluvial soils on a floodplain terrace may have a very high potential for buried sites. A terrace is essentially a remnant of an older floodplain. And the drainage has become more entrenched since then and carved itself in deeper. And so the flooding that those terraces experience tend to be lower energy. And so they may have a higher potential because there is alluvial deposition, and it's more likely to be low energy alluvial deposition that's likely to bury sites instead of destroying them. If you have a soil that formed in residuum, which is decayed bedrock essentially in upland settings and on slopes, it doesn't really matter. They're probably very old soils, but again, you don't really need to know the soil order because there's no mechanism to bury a site that's in soil that formed in residuum on an upland ridge. So just think about the meaning of what you're seeing with this information and just don't rely on one piece of information to help you make these decisions. Because you can tell by that setting if it's on an upland ridge or slope and the parent material is bedrock, there's no mechanism to bury sites. And so any sites that you see in that setting are going to be at or near the surface. So if you are thinking about the parent material in terms of whether you need to do deep testing, I would offer that this might be a useful way to try to think about it when you're looking at those soil orders and the other soil information. And it's an alluvial soil, which is where we would want to look for buried sites, except again, in specific exceptions. So from oldest to youngest here, is your alluvium that you're seeing likely to be early Holocene alluvium? And so it's very likely that you'll be seeing alpha sols there. But again, that's, it's not necessarily limited. Alpha sols are not necessarily limited to the Pleistocene, depending upon where you're looking. So they can have been deposited well into the Holocene era. So if you're in a place where you have alluvial soils that are alpha sols, might they be early Holocene alluvium? And you can find buried sites. They're likely to be older buried sites. And, these soils have been observed to have high Munsell values, well-developed BT horizons. You may see that E horizon if it has formed and been preserved. You may see things like thick clay skins on the beds. Also modeling and redox features. This is interesting, and I'll come back to it. Can be very characteristic in some of these older, early Holocene alluvium. And you may be thinking, well, when I see redox features, I think that that's a hydric soil, and I'll come back to that. But it's not necessarily the case. If the redox features are in a hydric soil, well, yes, then that's probably low potential, but they may not be. But moving through time, late Holocene alluvium Then your mollisols and inceptisols, here we're over the order of back thousands of years, but not many thousands. You can see also buried late Archaic to woodland period sites have been observed in these late Holocene alluvial settings. Lower achromas, lower Munsell values, less modeling, faint or absent. Unless something has happened and the soil has become periodically inundated since it was originally set down, then you might see redox features in there, but not characteristic. And post-settlement alluvium, which is much more recent. These are your entasols and inceptisols. You'll often see laminae of silt and sand, finely stratified material in there. But you know, they're depending on the setting. If it's in a high energy depositional environment, then maybe not. But if not, there can be site potential. Late pre-contact sites have been identified in inceptisols. Late pre-contact to historical period sites have been identified buried in entasols. So, you know, you need to look at the soil order along with some of those other pieces of information to try to form a more nuanced picture of the potential for buried site deposits. If you think there's a potential for buried site deposits, then it is useful to do some limited augering during your phase 1A to try to clear that up. The goal of augering during the phase 1A investigation, keep this in mind, it's not to find buried sites. You're trying to evaluate the potential for the soil to possibly contain buried sites. So if you fail to hit archaeological deposits in your auger, yeah, note that, but that's not necessarily negative evidence that a site is not there when you're doing very limited augering. It's kind of like if you're shovel probing on a site that has features, you know, what are the odds that your shovel probe is going to land in a feature? Yeah, it happens, but it's, you know, I would definitely not place bets on it happening. Same thing here. If you're augering, putting a few augers in a landscape that has landforms that might be suitable, that might have potential for buried sites, you know, the chance of your auger actually hitting one of those sites, it could happen, and it does happen, but the fact that it doesn't happen isn't that meaningful, because what we're really looking for, again, is that subsurface potential. So we're looking to verify that it's what kind of soil? An alluvial soil. Does it appear to be alluvial? Or do you put your auger in and find, actually, this soil does not appear to be alluvial at all, despite the way it was mapped, because the classification's not the soil. And you're looking, if it is alluvial, for evidence that it's formed in a low energy depositional environment, as I said. So you're looking for finer grained sediments. If your auger's going down and you're hitting pure sand or coarse sand, sand and gravel, that might be alluvial, but that's a pretty good indication that it's a high energy depositional environment. And that even if there had been sites there before that alluvium was deposited, that alluviation itself probably scoured away the upper portion of the previous soil and any archaeological sites along with it. So that's a sign that you have a low potential area. And the soils, you should also see that they did not form under very poorly drained or hydric conditions, because that means that the soil is persistently wet. And so it's fairly unlikely that there would have been sites there. So if you see something like an alluvial soil that formed, a poorly drained alluvial soil, or very poorly drained, that formed in depressions on tillplains, you know, those depressions were wet. People weren't hanging out in them doing activities that would result in the creation of significant archaeological sites. So even if there is alluviation in there, you know, that alluvium in that poorly drained setting tells you that there's a very poor site potential in that case. Higher potential landforms, floodplains, obviously, but that depends because floodplains, when the river overflows, are more subject to scour, and that can be damaging to sites. Interesting setting that we saw recently on the I-69 Ohio River Crossings project. There was a buried ridge and swale topography on the floodplain. The current ground surface was flat, but prior to alluviation, it had formed ridges and swales, and a number of those ridges had buried archaeological sites on them under the alluvium. Terraces. Terraces are a better setting even than floodplains because they may still flood, but again, they're more likely to be subject to low energy alluvial deposition, less likely to have their sites destroyed if sites are present, more likely for those sites to be buried intact. Natural levees, alluvial fans, those are also settings that may be higher potential landforms. This is not an exhaustive list. These are just some common ones that we've seen. Low potential landforms, uplands, very unlikely to have alluvial deposition, very unlikely to have buried sites. Side slopes, probably more likely to erode than to grade and also have a low buried site potential. Low site potential in general if they're steeply sloping, apart from dump sites or rock shelters or very specific things. Glacial landforms, extremely low potential for buried sites because again, they formed in soils that were deposited a very, very long time ago. And there's, in general, unless there is some localized mechanism that might have buried sites, say there's alluviation that's taken place recently that might have buried archaic or woodland period sites that are much later than the age of the glacial landform. There could be strange things, but as a rule of thumb, these are low potential settings in landforms. Stable landforms are important. So the surface had to have been stable long enough to support significant cultural occupation before it was buried. It has to have been a stable surface long enough for people to go there and make sites, if you will, for those sites to get buried in the first place. So horizonation is something to look at when you are, say, augering and looking and making decisions about deep testing. What about buried A horizons? I know people get very excited sometimes when they encountered a buried A horizon. But what does that mean? Well, a buried A horizon is not necessary for there to be buried sites. I mean, if you think about it, a buried A horizon in general is no more or less likely to have sites than an A horizon that's not buried. The site potential doesn't increase because it's become buried. So, it has to be one of those stable landforms that's in a setting that would be likely to have sites, and we don't always know that, and that's why we go out and do reconnaissance. But what is a buried A horizon does tell us, it's a good indication that there was a stable landform, that landform was stable at least long enough for that A horizon to develop or begin to develop before it became buried. And if that A horizon is still there, that also tells us that it was probably buried by some low energy alluvial deposition that did not scour away that A horizon. So a buried A horizon is a good indication of an intact, stable, buried landform, which is something that should make you be cautious about the potential for buried sites to be there. Because if there were sites there in that kind of a setting, that's a good indication to you that those sites are probably still there. But that's the majority of what it tells you, really, because again, that buried A horizon, that's not necessary for buried sites. And the majority of the buried sites that I've seen over the last so many years have been in stacked B horizons, stratified B horizons that either did not have an A horizon or the A horizon was stripped away, but still left cultural deposits and features in those B horizons through these repeated series of alluvial depositions. And so if you are in alluvial soils that are in a good setting and they seem to be of a reasonable age for that setting, and you don't see a buried A horizon, there could still be sites, buried sites preserved if you are seeing multiple B horizons below the surface. So just to repeat, another thing to consider, the depositional environment. Fine grade sediments are good because they indicate low energy deposition, more likely to preserve in buried sites. Coarse sediments have less good indications for buried site potential. Drainage, which I've alluded to. You may have alluvial soils and they may seem to be of a reasonable age for the setting that they are in, but if they're classified as very poorly drained and hydric, that's a pretty good indication. We'd like to see that backed up, in your shovel probing, that you actually are encountering hydric soils. And hydric soils are a complex topic that I'm not going to go far into. The definition of them involves a lot of technical issues, like the depth of the organic material, organic stratum at the top and things. We don't really care. What we care about, whether it's technically a hydric soil or just a really good look-alike to a hydric soil that wouldn't technically be classified as hydric. What we care about is that these are soils that formed in anaerobic conditions. They lacked access to oxygen as the soil was being formed. And the reason there was no oxygen is because they were persistently wet. They're constantly saturated soils. And as you might imagine, constantly saturated soils are not a high site potential environment, whether it's at the surface or buried. And so you can recognize those soils because that lack of oxygen, instead of an oxidizing environment where you have iron oxides that give you those nice brown, yellow, orange, reddish, rusty colors that you would associate with iron, you have a reducing environment, and that gives you the absence of those colors, which you see gleyed soils, gley colors, depleted soil matrix colors, which are generally gray, dark gray to light ashy gray. Gleyed soils, you can get your grays blending into greenish, bluish colors. If you've seen gleyed soils, they look pretty icky. Redox features can be apparent in a lot of hydric soils, especially if there's a fluctuating water table. The important thing is that they're associated with those gleyed soils or those depleted matrices. You can see redox features, redoxamorphic features. Before I'm ahead of myself, you can also see very different types of hydric soils that may not have those gley colors or those depleted matrix colors. They may be very dark. They may be high in organics. They may have formed in muck or peat, things like that. So, they're still likely still wet. And obviously, if you're encountering peat that's preserved, that's a pretty good sign that that soil was wet for a long time as it formed. But anyway, not to get too far into the weeds again on hydric soils, but if you do identify hydric soils, then that's probably a pretty good indicator of low site potential. Just point out that redoxamorphic features form from periodic wetting and drying. That can be a fluctuating water table or other periodic wet, dry conditions. You can see those features develop in hydric soils, and they are a characteristic of hydric soils, but you can see them in non-hydric soils. Again, if there's a soil that floods, a well-drained soil that floods periodically, a well-drained soil is unlikely to be a hydric soil, but it may have redoxamorphic features in them. And I guess in case you don't know what I mean by redoxamorphic features, that means that they're exposed to reducing and oxidizing atmospheres. So they're in an oxidizing atmosphere when they're dry and oxygen can get to the soil, and they're in a reducing atmosphere when it's wet. when the soil is inundated, some of the minerals in the soil are in a form that can dissolve and be transported along the water that's saturating the soil, particularly iron and manganese. And so when that soil dries, those materials, they may have started out evenly distributed in the soil, but as the soil wets and dries, they tend to clump together and they tend to accumulate along, might be along PEDs, might be along burrows or root molds that are in there, but they will tend to start to accumulate. And so as those do accumulate, you will start to see depletion in the rest of the soil as your iron concentrates in zones or nodules. The rest of it tends to become grayer. But that's not necessarily a sign that it's a hydric soil, particularly if it's a well-drained soil. So don't assume that redoxamorphic features mean that it's a hydric soil that has a low site potential. And don't forget, I mentioned that redoxamorphic features are characteristic of early Holocene alluvium, which can be alpha sols that formed during the earlier portion of the Holocene and can have buried sites. And we've observed this in some of the deep work that we've done. For instance, some work that we did in Floyd County, very close to Caesar's Casino. We had buried stratified cultural deposits in soils that had very clear redoxamorphic features in the upper levels. So if you were augering and you hit those redoxamorphic features in the upper strata, and you said, oh, this soil has low potential because it's a hydric soil. Well, no, it was not a hydric soil. It's just that it's been periodically inundated and dried at some point over time. And so, don't take that again as one specific piece of evidence in isolation that a soil might lack the potential for buried deposits. You really need to think about the combination of these things that I've been talking about to make a really well-informed decision. But in the end, what it really comes down to is, what do you see in the field? Again, I'll say it one more time, maybe more than once, I don't know, I can't promise. The classification is not the soil. So what you see in your desktop review will help you form an impression, the potential for buried deposits. And it may very well, in a lot of cases, tell you enough to know that there's no potential for buried deposits in your survey area. But if there is a chance, just look at the dirt, because that's what's really important, regardless of what soil is mapped or how it's classified. What are the characteristics of the soil that you're actually seeing in your survey area? That's what your recommendation should always be based on. That's the foundation of what you're looking at, more than the soil map of the classifications or anything else. Like, when you see and touch that dirt, is it consistent with what's mapped and what's classified? Is it consistent with what you understand to be a good setting for the preservation of sites and the burial of intact sites? So if you have questions about that, or if you think there is potential, I always recommend using an auger to find out. I like to dig a shovel probe first and then just use my auger to extend it. Because frankly, why not? Your shovel probe is a better window into that, say, upper 50 centimeters. So take advantage of it and then just use your auger to see what's below that and see if you can get down to the parent material, or if you see high energy deposits, or if you're seeing glade soils down low, then maybe that's a contraindication. And it's just always good practice to take an auger. So for some reason you're doing a survey, even if you're not in alluvial soils, maybe you unexpectedly have historical fill, or maybe it's just a particularly deep soil. If it's a particularly deep soil, you could have a horizon that extends below your plow zone that's hard to reach. It's just always good good practice, in my opinion. If you can't get through your A horizon with a shovel probe, stick an auger in and see what's down there, even if you're not in an alluvial setting. If you are in an alluvial setting, try to test some different portions of the area that's mapped as alluvium. You may find out that the actual extent of the alluvium is not the same as what's on the map. And again, I'd caution that the land, if there's a buried landform with sites on it, that landform might be very different than the potentially flat surface that you're seeing now, like that buried ridge and swale, or other cases where we find buried sites, but they're not at a consistent depth across the landscape because the buried surface was more undulating or dissected, perhaps. And so the sites were in specific higher areas of it, kind of similar. And then when they became buried, we can't just say, oh, well, we hit the buried sites at 50 centimeters, because it might be 60 centimeters here, it might be 1.20 meters there, So the current land surface is not a good indication. But that's another reason to do multiple augers across that land surface, because you might get an indication of that the depth of the alluvium varies across that area. And it's just good, it gives you more information than just sticking in a single auger does. Again, if you're in a small zone of alluvial soils next to a tiny drainage, one auger might be more than sufficient to show you that you've just got like a shallow layer of alluvium over channel deposits or glacial till or something like that. But if you're in a bigger area, we're not trying to do a phase 1C here, but multiple augers spread out or placed in what appear to be areas of topographic difference currently, that's good practice, and I would highly encourage that. So for instance, if you are by a drainage, you might want to put some nearer the drainage, farther away, to see how the depth of the alluvium varies there and what's under that alluvium, because that can really be useful information when you're going back and trying to make a recommendation for or justifying a recommendation against deep testing. So kind of sum this all up, inspired by the Geoarchaeology Task Force at SAA, I put together what I hope is a simpler sort of little flow chart that you can look at. And again, it begins with the desktop review. And really the first question to ask yourself is, do I have alluvial soils? If your answer is no, probably don't need deep testing. Again, and I didn't want to write this out, so I've included this, except if you have potential historical fill, or if it's in an area where you suspect that there might be colluvium burying deposits. In that case, then I would still recommend, doing your phase 1A auger testing if you can identify that at the desktop review stage. Or if you're out in the field and you see an area where like, I wonder about colluvium here, you might stick your auger in if you feel like there is colluvium that you can't get through with your shovel. But sticking with alluvial soils, if your answer is no, probably no deep testing. If your answer is yes, unless you can rule it out at the desktop level, because the alluvial soil is an alpha sol that's in a glacial setting or something like that, by a very small creek that's unlikely to have, you might be able to rule it out, but it never hurts to stick an auger in if you have alluvial soils, just in case, because again, the classification is not the soil, and knowing what the soil actually is 100%. So consider auger testing. So then if you're augering or shovel probing even before you auger, your next question is, am I actually seeing alluvial soils? If your answer is no, probably don't need deep testing, again, except in those sort of rare circumstances that might warrant it. If your answer is yes, this does appear to be an alluvial soil, is it poorly drained? Does it show, it might be classified as poorly drained, but are you seeing that it is literally a poorly drained or even hydric soil? And again, this is when you're going to be seeing those mucky soils or those severely reduced matrices with pronounced redox features in them, or glaying below the surface. you know, those, if you're seeing things like that, that's probably an indication that you don't need deep testing. If your answer is no, it does not appear to be poorly drained because you don't see those things. I would ask myself, well, does this appear to be high energy deposition that resulted in this layer of alluvium? Am I seeing sands, coarse coarse sand, gravel, things like that that are going to tell me that, yeah, this is alluvium, but you know, it's clearly when it was deposited, it scoured away anything that was potentially there. If your answer is yes, and you see that, you probably don't need deep testing. If you're going along this line, and after you identify alluvial soils and start testing, you know, if your answer is no, not poorly drained, no, not high energy, because you're seeing fine energy sediments like silt and clays, silty clay loam even. That's when you're probably going to ask yourself, well, it looks like maybe I need to recommend a phase 1C here. Even if you didn't happen to hit any deeply buried sites with those few augers you put in, remember the goal at the phase 1A level is to test the potential for buried sites, not to actually identify them. Your phase 1C reconnaissance that you will be recommending or not, that's where you would be looking for the buried sites. So I hope this kind of summarizes what I've covered today in a way that's sort of meaningful and not too confusing, and maybe would have a little bit of utility for you, kind of wrapping your mind around this, or just as a reference for part of the thought process. And, you know, obviously I did not go into the detail here about looking at the soil order and the parent material and the setting and the topography that you might want to consider, but those again are pretty significant factors to consider in combination with one another when you're doing your desktop review and thinking about what to expect and knowing what to look for when you go out and go through this decision-making process. And with that, I will open it up to you. I know I've said a ton of stuff here, but does anybody have any questions about any of the things that I've talked about today? Yes, David Moffat.
Not really a question. I just want to, well, thanks for this. First of all, this is great. I'd like to point out that, you know, flood events sometimes have different energy profiles based on where you are on the landform. So even if you hit, you know, the sand or gravels close to the creek or river, it may have a lower energy profile farther away. So another reason to do multiple augers.
Yeah, that's a great point. And I think you and I have probably both seen that I think in that particular scenario that you're mentioning, where you're likely to see the higher energy deposits closer to the drainage way, and you may have a better potential for low energy deposits as you get further away. And so yeah, 100%. Thanks, David. Any other thoughts or questions? Or did I just explain this so darn well that you feel like you might be?
The question is no.
Yeah, that's right. All right, great. I sort of anticipated some questions, and maybe some strongly worded questions. I don't know, or not. But if you do think of questions, you know, don't hesitate to reach out later. And like I said, I will share these slides and this flow chart, and of course, we'll share the video of this meeting with you soonish, as soon as we can get it up on our YouTube channel. And I'll send that information out as a listserv message so that you'll know to look for it. Last call for questions. All right. Well, thank you very much for joining us today, everybody. I hope you found it at least somewhat useful and that you will be able to maybe apply some of this information as you get out in the field. I know I enjoy talking to you all about soils since I don't get to go out and see them myself too often anymore. So, you know, if questions come up, as always, when you're out there and seeing something you're not sure how to interpret, not saying I'll know either, but I'd like to talk to you about it if you want to give me a shout. So thanks again, everybody, for joining us, and talk to you again soon.
Thanks, Matt.